Hello. Today we are talking about translations and rotations. We're going to start with translations. So translations you've seen before. You've probably seen in middle school and they were probably a slide. So in this case, we're calling it a translation and we're talking about triangle ABC. I'm going to scroll down a little bit. We're going to determine how we've been translated. So it looks like point A here should match up with this point right here, which means this would be A prime. And I'm just going to count and figure out how many units did I go in the left direction and then down. So there are two blanks over here. The first one wants the number of units. The second blank wants the direction. Left, right, up, down. That's it. So let's look at A. I'm going to go backwards 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like I went back 10 units. So I'm going to write down that it was translated 10 units and I need to give the direction. That direction was left. So we're going to do the same thing with our vertical distance. So then from here, I'm going to travel down 1, 2, 3. And so that is 3 units going, the direction is down. So I can do this for each. It should match up for every single vertex. So I'm going to go ahead and just do C and count and make sure that it is the same. So if I go left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I go down 3, 1, 2, 3, I end up at C prime, and then it should be the same for B as well, so that should be B prime. So the image formed is triangle A prime, B prime, C prime. So moving on to the next page. So for the next page, we're saying the pre-image of our quadrilateral, translate the pre-image, left 2 units and down 5, and then name the image using prime notation and list the coordinates of the new image. So because I'm listing the coordinates of the new image, we have another method that we can do this one. So if I start with what W is, and I'm going to write down the coordinates of the current point W. So that current point is 2, because I went over 2 and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm at 2, 9. So with this transformation, it says to go left 2 units. Left 2 units is the same as going in the negative direction 2 units, because if I go left, I'm going in the negative direction. The down 5 units would be going in the negative 5 direction, in the y direction, negative 5 units. So if I just take my translation and I put it right here, I'm going to end up with finding my new W. So my new W, 2 minus 2 is 0, and 9 minus 5 is 4. So the coordinates of W prime are going to be 0, 4. And again, I can do that by counting on the grid, or I can do that by working this out. So what I'd like you to do now is do that method for point C. So I'd like you to write down the coordinates for point C. Then I want you to subtract 2 from the x, subtract 2 from the y, and find your new coordinate for C. So go ahead and do that now, please. So here I have point C, and C prime ends up at 0, 0. So I'm going to go ahead and plot those points. And then I'm going to go ahead and count for the rest of them. So for U, Picking up with U at the top, I'm going to go left 2 units, down 5. 1, 2, 1, 2, 3, 4, 5. And that makes sense because U and W make a horizontal line. And lastly, I'm going to work with P. And from P, I'm going to go left 2, down 5. And here's my new P. So I have my new figure. Right here, and I can write down my coordinates. So my P prime end up at 5, -2. My U prime ends up at 5, 4. And my C prime I already had was at 0, 0. Moving on to the next page. So pause the video if you're not ready. So we're going to go ahead and do this one. I would like for you to try this one. So please pause the video now and complete this translation. Be sure you write your coordinates down as well. Here are my solutions. So pause the video here so that you can check your answers and make any changes. So now we're moving on to this one. James is doing his homework and he's stumped. So write step-by-step directions. Given A, B, and C, translate A, B, C, right 3 units and down 4 units. So what I'd like you to do right now, I want you to do this one as well. I want you to write step-by-step directions for James. So please pause the video now and write your directions and complete the translation. Here is my solution, so be sure and check your graph to make sure that your points are where my points are. The points are also written in blue at the bottom of your screen. You may use either method. I wrote one method in blue. I wrote another method in red. You may use whichever method you like. I'm never going to force you into one of the methods. If you have a problem where the graph is not given to you, simply ask for graph paper, and you may do it graphically, or you may do it without the graph. We typically ask for both. So pause the video now if you need to go over this problem. Moving on to the next one. Taylor stated that QRS was translated left 4 and down 2. Explain in a sentence or two why this is incorrect. Okay, so let's see. Let's start with just S. So S, if it had been moved left 4 units, 1, 2, 3, 4, and then down 2 units, 1, 2, then S prime would be right here. So what did Taylor do? Let's see what Taylor actually did. I'm going to put that in blue. This translation is left 2 and down 4. So she just reversed her direction. So Taylor, you can write this down on your lines. I'm going to write it right here so I don't have to move my screen. Taylor switched her directions. Her left should be down, and her down should be left. And go ahead, again, if you need to pause the video to write that down, go ahead and pause the video. We are moving on to rotations. So we have rotations. What a cute little rotation right there on the cover page. Moving on to the first problem. So here we have the solid figure is the pre-image and the dashed figure is the image after a transformation. So what is this transformation? And this transformation is a rotation. So whenever we have a rotation, we have certain things that we need to say. We need to identify what was the angle of rotation. We need to identify the direction. That's going to be clockwise or counterclockwise. So we have to know what clockwise means. Okay, clockwise is the direction that the clocks move, which is that way. Counterclockwise is the opposite direction, which is that way. About a point, we have to rotate something about a point. Let's go back to our angle of rotation. That's either going to be 90 degrees, 180 degrees, 270 degrees. You're going to have those, and we'll talk about other angles of rotation. We talk about different figures. So with this one, we first have to figure out, well, maybe we want to figure out our direction. I'm not sure, but in this, we started here with the solid and we ended up at the dashed. So it looks like we're going this direction, and that direction is considered clockwise. So our direction is going to be clockwise for this. So the next question is, how many degrees did we go? Well, basically each quadrant, so to speak, that you move, you're going 90 degrees. So this would be a 90-degree rotation. If our dashed image was down here somewhere, that would be an additional 90, which would be a 180-degree rotation. So this one is simply 90 degrees. What we also need to know is, well, what is the center of my rotation? So for the center of my rotation, what we can do is this one's a little bit, I would say this one's a little bit tricky to kind of see what the center of the rotation was. But basically, when I start at this point, and most of our rotations are going to be about the center, just to key you in. When I count to this point that I've got an X, I count up 1, 2, 3, 4, and then I count over 2. When I actually complete a rotation, I reverse those. So I would go over, instead of going up 4, I would go over 4. And instead of going left 2, I would go up 2. And this is where that point ends up. So with the center of my rotation, it is going to be 0, 0 in this case. So when I have the center of my rotation right here, and I connect the ending vertex and the starting vertex with this angle, that angle creates the angle of my rotation, which is 90 degrees. So this has been rotated about the origin, which is at the point 0, 0. And again, I forgot to write down my angle of rotation, which is 90 degrees. If there's anything you still need to write down, pause the video here. We are moving on to the next page. So the solid is the pre-image, the dashed is the image after a transformation. So with this transformation, I can see it's not a reflection, because if I were to kind of draw in a line of reflection, this point should end up over here somewhere, and the triangle is not in the same orientation. So I know that this isn't a reflection. I know it's not a translation because of the orientation again of the triangle. This point right here matches up with this point over here, so it couldn't be a translation, which means I'm left with a rotation. So with my rotation, I now know that it is a rotation, and let's figure out the angle of the rotation. So basically I've gone 2 quadrants. I would go from here to here, and then from here to there, which means I went 2 quadrants. That's 180 degrees. So now my question is, did I go clockwise or counterclockwise? So what I have drawn is counterclockwise, but let's look at the clockwise version. I would go from here to here, and then from here to there, which would be 180 degrees as well. So with 180 degrees, does it matter the direction? And the answer is no. When you say it's 180 degrees, you do not need to say clockwise or counterclockwise, because no matter what, you're going to get the exact same place, whether I go clockwise or I go counterclockwise with 180 degree rotation. Now for this one, we need to find the center. And this one's a pretty simple one to find the center. When it's 180 degree rotation, this is only for 180 degree rotation. Only this one. You can connect points that match up. So this vertex I've marked with an X matches up with this other vertex I've marked with an X. Now if you had a ruler, it would be much better. I don't have a ruler, so I'm hand drawing in. I'm going to draw the line that connects those two. So there's my line. It was terrible. Really, that was terrible. Now I'm going to draw in another one. So let's see. This one in blue matches up with this one, which means I'm going to draw that line. That was terrible too. And then I have the last one. Green matches up with green, and I have this one. Now, my lines are terrible, so again, let me reiterate. Terrible. I believe the center of this rotation is 0, 0, and it should be where all three lines meet. All three of those lines should meet right there. And again, that only works for a 180-degree rotation. But let me just check. When I count over and up from the center of the rotation to the green point, I go 1, 2, 3, 4, 1, 2. I should do the same thing in the opposite direction. 1, 2, 3, 4, 1, 2, and I do, which means the center of rotation is at 0, 0. And again, our rotations are typically going to be about the point 0, 0, so we're going to make things hopefully easier for you. Moving on to the next page. I am not going to read this page, but I want you to read this page. So please pause the video, read this page, then we'll move on and do a problem together. But it's important that you read this first. So pause the video, please. So here we are moving on to doing a problem. I'm going to actually start with the 90-degree clockwise problem first, and then I'm going to have, no, actually, I'm going to do the, yeah, I'll do the 90. So for the 90 degrees clockwise, what we're going to do is we're going to go clockwise, and again, clockwise goes like this, which means we're going to end up in this quadrant for my new figure. So I'm going to my rotation is centered at 0, 0. I'm going to count to this first blue X, and I'm always going to count over and down. In this case, it was 2 and 2, which means to get into my other quadrant, I'm going to go from the origin again, back to the origin, up 2 and over 2. So I do the same sort of direction. I'm going to switch them though. So let's go ahead and look at this green point here. From the origin, I'm going to go over 1, 2, 3, and I'm going to go down 1, 2, 3, 4, 5. I'm going to switch that when I go back to my origin. Instead of going over 3, I'm going to go over 5. So I'm going to go over 3, 4, 5, and then I'm going to go up 3. 1, 2, 3. So here is the green point. Sorry, I'm going to erase some of this. Put my blue point back. Now I'm going to move on. Let's try this red point here. And again, I count over and down. I go over 1, 2, 3, 4, 5, and I go down, write that down, and I go down 1, 2, 3, 4, 5, which means I'm going to go over 5 and up 5. And here's my red point. And I'm going to do a black point, and that one I'm going to go over 1, 2, 3, 4, 5, 6, and down 2. So I'm going to go over 2 and up 6. And here I am with that point. And then I should be able to draw my figure. So my figure, sorry, just want to make it larger. My figure is going to be like that. And that is after a 90-degree clockwise rotation. So now I want to do that one first and then talk about this 270. 270 counterclockwise. Let's sort of figure out where we're going to end up. Counterclockwise means I'm going this direction. So from here to here, that's 90 degrees. From here to here, that's 180 degrees. From here to here, that's another 90, sorry, that's another 90, which is 270. So basically I'm going to end up in this quadrant again. So I'm essentially going to end up with the same figure. I would like you to pause the video and actually calculate that one yourself. So please pause the video now and complete this first 270 counterclockwise rotation. Pause, please. Okay, so we are now moving on to our angles of rotations with polygons. Not bad stuff. Okay, so the angle of rotation is going to be 360 divided by n, and n is the number of sides of the polygon. So the angle of rotation is each angle in the center of the figure. So typically when we give you a figure though, we're not going to have all these triangles drawn in. We're just going to give you this and say, okay, what's the angle of rotation? But you can see what I've done from the figure I've drawn to the figure I've given you is I've drawn in all these triangles. And all I'm doing is drawing in diagonals, connecting vertices. And I draw them in, and you can see all the triangles that I have. I know that all the way around is 360 degrees, and in this case I just need to count the triangles. 1, 2, 3, 4, 5, 6. That means my angle of rotation is 360 divided by 6, which is 60 degrees. Okay, great. What does that mean? That means if I go from Z to W, I have rotated 60 degrees. If I go from Z to V, I've rotated 260 degrees, which is 120 degrees, etc. Did I just answer that question? I did. Number one, what is the image of Z under 120 degree clockwise rotations? That means two 60-degree rotations. So I just go two vertices over, essentially, and I end up at V. Next question is, what is the angle of rotation from V to N? So to go from V to N is also going to be 60 degrees. What is the image? Let me scroll down. What is the image of BC? Okay, so we're talking about this line segment. It's very important to maintain the order. Okay, the order of the letters matters here. So BC under a 300-degree counterclockwise rotation. Okay, we can do this. Don't worry, we can do this. So we're going to do 300 degrees. How many 60s is that? Okay, let's see. That's 5. That's 5 60s. 5 60s. Counterclockwise means we're going that direction. Okay, so we're starting with BC. From here to here, that's 1. From here to here, that's 2. From here to here, that's 3. From here to here, that's 4. From here to here, that's 5 60 degrees. So let's follow B. B was here. Then after one rotation, it was on N. After another, it was on V. After another, it was on X. After another, it was on Z. And after the fifth one, it's on C. So my B matches up with C, and my Z matches up with my original C. So I end up at CZ. So instead of doing 300-degree counterclockwise rotation, what's the other rotation I could have done? Well, I could have just done a 60-degree clockwise rotation because all the way around is 360. I wanted to go 300 degrees in the opposite direction, so change your direction and finish off your 360 by going 60 degrees that way. So that's the other way that you could have done it. I think that would have been a lot easier. So I'd like for you to try numbers 4 and 5 right now. So you try these, pause the video now, please. Here are your answers. Number 4 is segment NO. The letters must be in that order. And number 5 is B. So write down any questions that you have from this packet and bring them to class next time, and have a wonderful evening.